There you go.
Oh, that was loud. All right. Well, we certainly know that we're recording now, so that's good. All righty. You are building event-driven applications using Azure. My name is Dustin Ewers. I'm a consultant at Centair, and we are also hiring. So if you want to check us out, we can go. You can go to the website, send me a message, whatever you want to do. My contact information is also here. So website, LinkedIn, that sort of deal. All the code and slides and things for this presentation are at the GitHub repo at the bottom of the slide, which we'll show at the end as well, so that we have it in both situations. Just a little bit, if you have a question, go ahead and shout it out or throw it in the chat. Jason said he's going to ping me, so he's going to monitor that kindly. So just ask whatever, whenever, and I will try to answer it as best I can. We have a little bit of extra time because, it's not like we don't have a super tight time block. So we can ask questions as needed. So with that, let's get it going. So I want to kick this off with my backstory on this. A lot of times, ones that I kind of get called into more often than I like is you have a project, that project starts, and then things kind of go a little haywire. And that seems to be when they call me. That's not always the case, but it's often enough that has been the case that has become kind of a thing. And this project is definitely not an exception. So the story of this project is they built something, and it was an actuarial calculation. And so the idea is that you have a mortality table that has a bunch of actuarial data, and then that table is used to craft a very resource intensive calculation that determines some predictive modeling. And when they architected that application initially, the way they built it was in a very linear way. And they built the application, just as a standard batch process. It runs, and their goal is to use as many of the CPU cores as possible so that they maximize the CPU being used. And the problem with that is that those CPUs also happen to be shared with their production server. So you have this situation where, if you remember when you were a kid and you watched the cartoon with Daffy Duck and he drank all the explosives and then he blew up, and then he's like, it's a really great trick and he can only do it once. Well, that's this application, because it ran great in test and it ran great in development because you weren't using that much data. But when it got to production, it blew up not only itself, it also blew up the database that it was running. And brought down the entire system in a big ball of fiery goodness, which is not a good time. And that's the point where they called me in to help out and try and turn things around. And so what I ended up doing is, with the assistance of the team, we re-architected the application from an on-prem, just standard monolithic app into a more service-oriented, event-driven application. So that's where a lot of the experience for this comes from, is this project where we took this application that was kind of a mess and we made it run really well. So we took this from an application that took over a day and blew up the production environment to an application that runs the same process in about 15 minutes using the cloud and event-driven architecture. We're going to wait for the paper shuffling. All right. So using the cloud and event-driven architecture, we took this thing from a day to about 15 minutes. I'd say that's pretty good. And so our roadmap for today is we're going to talk about what and why, the what and why of event-driven architecture. We're going to talk about some different patterns. We're going to talk about when to use those patterns. And we're going to talk about when not to use those patterns. Then we're going to talk about how to use event-driven architecture, specifically in Azure. And then finally, we're going to kick it off with a demo. Looks like we got some folks that might want to mute. So we'll give that a second.
what I could do is mute everyone, and then you can unmute yourself, Dustin.
All right, that sounds good.
3, 2, 1.
And we're back. Oh wow, that's a lot better. I'm all good with the clicking, but it kind of gets excessive at some point. So, all right, and so we're going to cap it off with a demo, and I'm actually going to show some different things, an actual workflow using event-driven architecture that you can check out. It's not going to be the batch process actuarial calculation for a variety of reasons, but it will be something that uses events to give you an idea of how to do this sort of thing. So what is event-driven architecture? Well, it's an architecture that deals with events. All right, that's cool. Peace out. We're done, right? No. It's one of those things where it kind of defines itself, but really what I want to do is I want to start off with a couple of different scenarios. And we can begin to define like what event-driven architecture is by some of the scenarios that different event patterns can address. So I want to start off with scenario 1, a monolith to microservice. So let's say you have a big monolithic application. It's hard to maintain. You want to break it down into some smaller pieces that are easier to maintain. And so you spend a period of time decomposing your giant monolith into a bunch of little microservices. Okay, that's cool. But here's the problem. Let's think about this for a minute. So we have a bunch of microservices, and those microservices depend on each other. So let's say that, for example, you have a customer service, and you have a customer that needs their order. So say you're building like a store or something. So a customer needs their order history. So from a microservices perspective, you'd go to the customer service to get customer data. And then you'd have to call an order service for order data. And that order service would, if you want the history, you'd have to go get product definitions. And you'd have to call a product service. And what you end up with is this kind of tangled mess of dependencies. And if you only have a few services, this isn't that big of a deal. It's not that much of a problem. But as you scale up to having a lot of different services, this becomes a tangled mess. And this pattern is referred to as a distributed monolith. So you still have all the same dependencies that your monolith had, except they're slower because now they're over a network. So not a good time. And so this is one situation that we can resolve with event-driven architecture. Scenario 2, long-running processes. There's a lot of different things that take a long time that you can't necessarily affect. A really common one is any kind of credit card payment or payment gateway. Those are usually run by the banks. Those are going to take a few seconds, and there's really nothing you can do about it from a development perspective. Additionally, you have things like talking to backend systems, like using stuff like BizTalk. You have media conversions, and finally you have batch processes. So you have processes that are either long running or slow or resource intensive. Another scenario is you have to track an inventory or a ledger. So let's say you have a store and you have an inventory, and you need to make sure that you have a history of all the different transactions that remove items from that inventory. But at the same time, you have a lot of different customer or different processes taking and adding to that inventory. So as people buy products, those are going to be individual orders that are reduced from the inventory. And the thing here is you really need to track history, and you really need to reduce conflicts. And the final scenario we're going to brush upon a little bit is any kind of large streaming data flow. So you have sensor readings or telemetry from monitoring systems. And the thing is, what do all these things have in common is that they all have some sort of event that occurs that you need to manage. And really, event-driven architecture is an architecture that deals with these sorts of events. And specifically, there's a couple of different components in any event-based architecture. You have events, you have event producers or message producers, you have message brokers, and then you have consumers. And specifically, what is an event? An event is any notable thing that happened. So, you have like a change in state. So you have like a new customer or a new order or a payment. You could have a temperature reading or a shopping cart checkout. And the key here is you want something that's lightweight and easily understood. So you don't want to send a book of data with your events, and you want to have events that are understood by the customer. You want them to be domain defined, not technically defined. And these events tend to move through the system as such. So you have producers that make the events, message broker, which is a component that sits between your producer and your consumers, that manages, queues, tracks those events. And then you have consumers that consume those events and potentially may produce other events that go with it. And there's a couple of different event patterns. And we'll go through these more in depth in a minute. So we have queues, topics, event sourcing, and event streaming. The first two are commonly referred to as pub sub patterns, though I split them out because they're generally used for different purposes in design. And the first one I want to talk about is queues. A queue is basically where your event, your message broker, basically collects all of the events and then individually distributes them to processors. So you have your queue, you have a list of events, and those events are processed individually by each component that pulls from that queue. And you have a single component that pulls from that queue, or you can have multiple components. So when I built the system that I built, we used a queue, and we had multiple processors that we scaled up and down depending on the size of the queue. And this is a really good pattern for scaling. It gives us the ability to load level, so we can easily scale up and down, or even if we don't scale up and down, we don't have a situation where we DDoS our downstream process because it's pulling from that queue. It's only taking as much as it can currently process. So instead of getting overwhelmed by a single big chunk of load, that process can handle things one at a time, which is really nice for processor intensive things. Additionally, if you have a batch process or if you're working in the cloud, you can alter the processes to control the flow rate. So you can increase your number of processors or decrease them, which is really easy in the cloud. And this is really nice for auto scaling. So that's the queue pattern. The next pattern is the topic pattern. So in a topic, instead of it sending each individual item to a single entity, so it's like a one-to-one relationship, instead it's more of a broadcast mechanic where your processor broadcasts your event out to a list of subscribers. So in this case, we have a customer service. Let's say we have some sort of customer update, like the customer had a new address. Then we broadcast it out to all the different subscribers to that end that need that information. And what this does is it promotes loosely coupled architecture. So one of the things is that if we didn't have this message broker in the middle, that this topic, the customer service would have to keep track of all the different things that had to update when you had a customer update. And this would, cause the customer service to be kind of the, dependent directly on these other subscribers. If you add this additional topic component, that no longer is the case. The customer service is completely independent. It just sends its data to the topic, and then the topic deals with all these additional downstream connections. And it's really easy to add subscribers down the road. The next pattern I want to talk about is event sourcing. Event sourcing is where you have an append-only log of events. So for example, we talked about our inventory, like an inventory would be adding, inventory or subtracting inventory. And instead of updating entities, you would add a new record for that. If you've done anything with accounting, accounting is basically event storing or event sourcing. And the way you get the current state with an event source system is that you replay your events. If sometimes you can, instead of replaying the events, hide that replay behind like a materialized view. So if you want to create like a SQL view, you can do that. And the one nice thing about event sourcing is it's really good for tracking history. So if you ever end up in a situation where you're creating like an audit table or you're trying to set up database triggers to make sure you have audit data for a particular thing, consider setting it up in an event sourcing pattern instead. That way you don't have to basically maintain two different states. And the final pattern that I'm not going to talk about a ton, not because it's bad, I just don't have a lot of experience in it, event streaming. And so this is a pattern that's super common in Internet of Things applications, and basically just involves large data flows that are often pulled for like an aggregate amount or an aggregate number, or you're looking at a particular data stream in a time sequence. So the key aspect here is that you have a lot of data, but you don't necessarily care about each individual discrete event. You're more looking at different aggregate functions. That makes sense. So these are the patterns and when they're used, but there's also pitfalls. So while there are some people that like to go to the most complicated architectural pattern they know for every problem, which is suboptimal to say the least. My personal opinion is that you should always start with the simplest possible pattern and scale up as needed to address particular problems in your software. And so everything in software architecture is a trade-off, and event-driven design is no different. And so here's a few things that you can run into. The first are a couple of problems I categorize under timey-wimey fun. So one of the problems with event-driven architecture is that it's asynchronous. And so instead of having a nice linear process that's really easy to understand, things can happen in a somewhat disjointed manner that causes that makes things a little bit more difficult. Specifically, the first one is consistency. So let's say that you have an update. That update gets dropped onto a queue to process, and then that information gets updated at some point in the future. Normally, if you're building an application, you're going to make that same update, go to the database, update the record, pull that record back out, and send it back up the chain to the UI to refresh the UI. But in event land, that doesn't necessarily work, because after you send that event to your event, your message broker, you don't know when that event's going to get processed. So you can't just go and grab the latest version, because that version is going to be out of date. And in some cases, it's going to be out of date very quickly. So this problem is also called eventual consistency. So you need to be aware that when you drop something in the queue, you can't just go and retrieve the updated data. Another problem is event delivery failures. Sometimes the events don't get where they need to go. There's various things that can happen, and you need to think about that. And additionally, you also have multiple processing of events. So sometimes, you might, for some reason, get more than one version of the same event. And so it's important to make sure that whatever event store you're using is, or whatever event processing logic you have in your application is idempotent, which is a fancy word that means that, if you do the same thing twice, it creates the same results. So you can't, you're not going to blow up your application by doing the same thing twice. The next problem, and this is something that happens in any microservices or other system with a lot of different parts, is the logging and tracking of events as they flow through the system. Now, if you have a situation where it's just like a producer, a broker, and a single processor, this really isn't going to be that big of a deal, especially if there's like an ID that you can associate with. But once you start scaling up to multiple, to a producer, sending something to a broker, which is processed by multiple things downstream, logging and tracking can get pretty dicey. So what you're going to want to do is you're going to create some sort of correlation ID that goes with your action as it crosses the different boundaries. Another fun event-related problem is the thundering herd problem. So this is specific to topics. So let's say you have a customer, they update, and you have a whole bunch of people that subscribe to that customer update. So what's going to happen is every time the customer service fires off an update, all of those downstream consumers are going to then hit the customer service to get more data out of it. And so basically, you're just creating this storm of activity. For every one thing that comes out of your one service, you get a bunch of requests from a bunch of different services that go with it. And there are a couple ways to handle this. The big one is to increase the size of your event and have a few more fields that go with it to try and reduce the downstream calling that goes with that. That makes sense. And really, what all these pitfalls come down to at the end of the day is it's just additional complexity. I'm going to show you a demo later, and you'll understand this because it's a very simple looking demo, but there's a whole bunch of code and stuff behind it to make it work. And this is really the big trade-off with event-driven architecture, is that you're getting either load leveling or decoupling or these other benefits, but at the end of the day, you're also paying for that benefit in additional complexity in your application that you then have to manage as a developer. Does that make sense to everybody? All right, cool. Rocking. All right, let's move on to the next section. So now that we understand the what and why, let's talk about how to do event-driven architecture in Azure specifically. Now, you can do these things in other cloud providers. You can do event-driven architecture on-prem. There's nothing wrong with any of the other approaches. It's just Azure is what I have experience in. And so we're going to do event-driven architecture in Azure. So I want to kick this off with a few cheap ways to do event-driven architecture. The first is a storage queue. So if you have a Azure storage account, which is incredibly cheap, you can get an Azure storage queue that goes with that account. And you can use that to build a basic queuing mechanism. I've seen processes that do this, and it's a little bit on the limited side. So it's cheap, but it's not super reliable. Personally, I wouldn't recommend it, but if there's a situation that for some reason you're not able to set up a service bus and all you can do is a storage account, this is a cheap queuing mechanism that you can employ. Another cheap way to do it is to use your existing database. So you can create a table or a schema of different tables to replicate many of the functions of a service bus, especially when we're talking about queues. So it's relatively easy to set up a database structure that queues up a bunch of items for future retrieval. This is something that might be a good idea if you have a batch process or a single thing you want to load level, but you don't necessarily want to go through all of the hassle of using like a full-blown service Azure service bus or other queuing mechanism. Yeah, and somebody said DBs as queues works, but are a nightmare to maintain. And that is accurate. And one of those things too, additionally, is that sometimes the sort of hack solution that you use to try and get past a certain requirement becomes the permanent solution that you use forever. I know a situation where somebody built a DIY service bus in a project, and they're like, okay, we're going to build this DIY service bus and replace it in a year or two. And, like 6 years later, they're still using the DIY service bus and haven't replaced it with anything. So be mindful of maintenance costs. So I'm not saying I recommend any of these cheap ways to do it. I'm just saying that there are cheap ways to do it. So be skeptical. If we move on to actual Azure services that deal with event-driven patterns, there's three big ones, and they all have very descriptive names that sound almost exactly the same. So you have the event grid, the event hub, and the service bus. And we're going to dig into each of these in the next couple slides. So the first one we have is the event grid. Azure Event Grid is sort of an undergirding Azure service that orchestrates a lot of Azure events, and it relies on a pub-sub architecture. So you basically subscribe to different events. And you can also use Event Grid on your own infrastructure, and you can create Event Grid events. But the primary use that I've seen it used in the wild is to orchestrate different Azure events. And one scenario that I've seen that's pretty interesting that I thought was cool is an organization used Azure Event Grid to monitor their databases. So you have an Azure database. That Azure database has a firewall. You want to make sure that firewall is configured in a particular way so that it stays secure. You don't want to open it up to everybody. You want that Azure firewall to be restricted to your company's known IPs. And so whenever you update an Azure database, it throws off an event grid event. And so there's a guardrail that subscribes to that event, does a check, and makes sure that database is configured correctly. If that database is not configured correctly for some reason, then it automatically fixes the database so that the firewall is correctly configured no matter what. And it's really good for creating these kind of guardrails and making sure that the infrastructure is secure. So that's one use for the event grid. The next service I want to talk about is the Azure Event Hub. This corresponds to the IoT streaming, event streaming pattern that we talked about earlier. And I haven't used this one a ton, but one of the things about Event Hub is that it's got really high throughput numbers. So when you're looking at all these different services and you're like, oh, which one should I use? This is going to be the one with the big numbers. And generally, you're going to not want to use the Azure Event Hub. Not because it's bad, but because most situations, at least the ones I'm in, deal with business events that are high value. And Event Hub deals with large amounts of telemetry or IoT data. They deal with data streams that tend to be processed streams, which each individual event is not terribly important. So just be aware that this is going to be the one with the big numbers, and it's probably not the one you want to use. And finally, I want to talk about the Azure Service Bus. The Azure Service Bus is meant for high-value business events. And what that means is that, if you have an event where you're doing like a credit card payment or something you definitely want to see get to your processor, Azure Service Bus is going to be your jam. So I would say in most line of business cases, this is going to be your default move out of the gate. Like I would start here. And specifically, like I talked about cheap ways and expensive ways to do it. The Azure Service Bus to start off with is actually pretty cheap too. If you get a standard tier and you're just using it for like a smallish application, it's approximately like $5 to $10 a month. So extremely cheap on the lower tiers. Once you scale up though, then the price escalates quickly if you start doing premium messaging. So specifically, we have business events. It supports the topic pattern and the queue pattern. And there's a couple of different service tiers. The big differences between the premium and the standard tier is the standard tier has more of a shared hosting model that's based on the volume of messages, whereas the premium has isolated compute. It supports different security scenarios and supports more security features. I think VNets is the big one. But it's also pretty expensive versus a standard issue Azure Service Bus. So it's one of those things where if you're a big enterprise, you're probably going to want premium and you're probably going to pay a lot of money for it. To access the Azure Service Bus, you have your choice of 3 different APIs. And this is something that might burn you when you're looking at the documentation, because when I started with Azure Service Bus, it definitely burned me. So when I started, I was basically the documentation was split between the Microsoft.Azure.Service Bus and the older Windows Azure.Service Bus API. So there was kind of both throughout the documentation, and it got real confusing real fast because the access models are slightly different. Of course, much like that XKCD cartoon where you have like one standard and then you create a standard to rule them all, and then you have N+1 standards. Microsoft has been good enough to create a new API to access the Azure Service Bus called Azure.Messaging.Service Bus. And this is the latest one. And the nice thing about this particular API is that it seems like the documentation has mostly migrated to the new flavor. And so most of the time when you're looking in the Microsoft docs, you're going to get pointed towards the new Azure Service Bus API. So that's cool. Just be aware that as you look through, code samples and docs and stuff, that there's 3 different APIs, and they're all fairly different, even though they do the same thing. And the key is to focus on the Azure.Messaging.Service Bus API. So good times there. That we could list that as a pitfall, but welcome to technology, stuff changes. And finally, if you want to test Service Bus locally on your machine, there is a program you can download. It's on GitHub called the Service Bus Explorer. And basically what you can do with it is you can drop in your Azure Service Bus connection string, and then you get a nice little GUI interface that you can use to look at your queues and subscriptions and topics and all those different other things. So it's a really nice way to get like a visual, the ability to visually edit and look at it and examine your development service buses. You probably don't want to use this for production use, but this is definitely a nice tool. I don't use it all the time, but I know people who do, and it's a handy thing to have. Any additional questions before we kick it off to the demo? All right, let's do it. Okay. So I'm going to give you one more slide before we go to the demo. And basically, I'm just going to talk about the scenario. So let's pretend for a minute. We're going to have to use our imaginations because I didn't spend a lot of time designing this application. Let's say that you're building a video game, right? And you're building a video game, a web-based video game. The first thing you need to do is you need to get paid. And so you're going to design a workflow to buy your in-game currency, your coins or diamonds or gems, or really whatever you're going to call the things. This is beta, so we're just going to call them coins. And so we have our main game application. So that's going to be a standard .NET application. The user is going to come in, they're going to buy their coins. That's going to kick off a request to the service bus queue that is going to take a few seconds because it's got to hit a payment gateway. And then what's going to happen is that queue is going to get processed by a function app. That function app is going to then load the results of that to a topic, which is then going to go back to the application, get processed via Signal R, and sends a toast notification, which mysteriously shows up as a list item on the user's screen. So this is going to be like the very simple looking, but there's a whole bunch of stuff that happens, and we're going to walk you through all of that. So let's get out of the PowerPoint here. There we go. So we're going to get out of the PowerPoint, and I'm going to start off with the infrastructure. Specifically, this is just spinning up our Azure Service Bus and its associated infrastructure. So we come in here, we're doing PowerShell. My personal recommendation is that if you're doing any kind of Azure work, you always write yourself a PowerShell or ARM templates or some other code-based solution, just because, especially if it's something expensive, it's nice to be able to destroy and recreate your infrastructure. I know a lot of people like to go in with the portal and explore that way, and that's fine if you're just doing a one-off. But if you're doing anything that you're going to want to recreate, I always like to script. So that's what we're going to do here. So we roll in here. The first thing we're going to do is we're going to create a resource group with AZ group create. Probably seen that before. The next thing we're going to do is we're going to create our service bus. And so you start off by creating a service bus namespace. So this is basically the URL for the service bus. So you have the namespace name here. And the key here is that this has to be unique. So I threw in a little prefix to make it unique, because if it is not unique among all service buses, it's not going to work. So you got to make sure it's unique. Once you have your namespace, the next thing you need to do is you need to create a queue. We're going to create a queue. So this is the queue that receives the payment request to process. So we drop in our resource group, our namespace, and our queue name. And that's it. The next thing we need to do is we need to create a topic. The topic is going to take the results of the payment and then broadcast that to all of the different subscribers that care about the payment results. So it looks a lot like the queue because it's pretty similar to the queue. Building topics and queues in Azure is a very similar process. Same goes with accessing them. But with the topics, you also have to create a subscription. And so in this case, we create our group name, bus name. we send in our topic name, and then we also send in a name for that subscription. So every time you want to subscribe to a topic, you have to create a new topic subscription to pull in those data, or to pull in that data. There's also a little bit of filtering you can do. So if you only care about certain events that meet some sort of criteria, you can also insert that here. But in this case, we're getting all of them because this is a demo app. Finally, we're going to create some credentials for our service bus. So there's a couple of different ways that you can lock down a service bus and provide permissions. One way that's convenient is using role-based authentication. So in that case, you give your application a service identity, and then you authenticate that service identity to your, or you authorize that service identity to access your service bus. And this is a really nice way to do things in an actual like production environment. Locally, it's also nice if you can also get whatever AD group you're in access as well. The downside of using this from a development perspective is that if you are running your Visual Studio as administrator, that doesn't work. Because if you're running it as local admin, you're not going to have the right, your program is going to run with the right credentials to access that service bus. So if you're running Visual Studio normally with your normal ID, then it should work fine as long as you're authorized. But if you're in one of those organizations that kind of forces you to run as admin, which is something that used to happen a lot and is happening less, then you're going to run into problems. So the other thing you can do is you create an authorization rule, and that authorization rule is going to give you a key that you can use to access your Azure Service Bus. So what we're going to do here is we basically create a rule. We then grab that rule using the list command. So we're pulling that out of the service bus, converting it from the JSON, which gives us a key object. And then we're going to spit that back out to get the namespace and the connection string, which looks kind of like this. So this is what the object it creates looks like. You can also pull this information out of the portal. So if you go here into the portal, you can go down to shared access policy, and then you can check out the different policies here. So in this case, this is the one that we created in the script. This is one I created because somebody wanted to know how to do it in the portal. And so we have our primary key, our secondary key, and our connection strings. Probably don't want to show these on the internet, but this is a demo app, so we'll get over it. So with that, that is our Azure infrastructure. In terms of the application is a very, very well-designed beta application that is not running currently because I didn't press the button. So we're going to fire that up. And so as said, we have an ASP.NET application, which is here. We also have a function application, which is right here. So if we put these side by side, we can kind of see things happen. So we're going to buy some in-game coins. We're going to buy however many coins, and then we're going to submit. This is actually sending it to the service bus. That's handling the purchase, dropping it into a topic, and then it comes back as successful. So every certain number of these is, and so we can just kind of fire these off and they'll come back, and I think a percentage of them are supposed to be unsuccessful, but as you can see, they're all good. So once these get going, we can do a lot of them. So let's talk about how we actually write that code. So if we hop back into our application, I'm just going to walk through the workflow from the user perspective. So we have our form. So if we look at this project, we have 3 different sub-projects. We have a web, which is going to be our ASP.NET application, the domain, which is kind of like shared entities that are shared between the projects, and then we have the API, which is Azure Function App. So starting here, if we come into our page, so we come into our store page, this is using Razor Pages, so it's kind of a simplified version of MVC. We're bringing the code behind back, folks. We're bringing it back. We have on posts, so when this form is posted, validates, takes the order model, adds a GUID to it so we can keep it nice and unique, adds a user, which we can pretend is from the user session, but this is demo code, so it's not. And then we are sending it to this service bus handle. We got some code behind lovers here. I feel like the code behind is one of those things that is used a lot. Like doing Angular, you also have a code behind. So clearly it's a model that works. And so what we're going to do is we're going to send this to the queue. And what I like to do as a general rule is any kind of infrastructure, I like to add a interface to just to kind of separate the application from the infrastructure. If you don't want to write your own for some reason, there's a library called mass transit, which you can implement if you want. I didn't do that because I just, this is one of those things that it's relatively simple and I don't need a third-party library to do something simple. Especially because I probably end up just abstracting the third-party library because, yay abstractions. So in this case, we have two methods on this handler. We have one to set up our topic listener, which we'll talk about later. And we have one to send the order to the queue. So if we come in here, the big thing we're doing is we are creating a service bus client in our constructor using the connection string, which we get from our config value, which comes from the data that we had in the script and in the portal. And so we throw in our connection string and we get a client. The next thing we're going to do is we're going to create a sender. So this is part of the library that I talked about before, that Azure messaging. We're going to create a sender, dropping in our queue name. And so this is going to send things to that queue. Shocking, right? And then the next thing we're going to do is we're going to create a new service bus message, and we are going to serialize our order object. So this takes a string. So we want to drop in our method, our JSON string, so we can deserialize it later. Then we have our message, and we send the message to the queue. That's it. 3 lines of code sends the message to the queue. Now, this is going to go to the queue, and then that is going to be handled by this function app here. And the thing is, function apps are really nice for this kind of like orchestration and glue code, because one of the triggers for an Azure function is getting something from a service bus queue. You don't have to set up your own handler for this. You can just use the service bus, or you can just use a function app, and it does most of that kind of glue code for you. And you'll see in a minute with the topics that, actually getting stuff out of the topics is a little bit, there's a little bit of ceremony there. And with the function app, there's like 0 ceremony. So it's kind of cool. So here's our function. It's the handle purchase function. We got a name. We come in here, and then we add this return variable. And what this does is it allows us to take the output of this function and drop it into a service bus topic. And so we're actually going to send this to the purchase updates topic when we are done. And the connection is the service bus connection, which is defined in the app settings of the function right here. So we have our service bus connection string, and that's how we link all that stuff up in this area right here. And so we're going to run. We have a service bus trigger. This is the trigger for the queue using the same connection and the service bus queue name. We drop in our string, which is our order message. And so we come in here, we deserialize our message back into the order. We send to our payment API, which is fake because this is demo code. The ultimate payment API is the one that just sleeps for 3 seconds and then either works or it doesn't. And then we end with a new order result record. So we have our order ID, our payment results, the user and the number of coins in that result. And we serialize that bad boy up and we send it to the topic. So at this point, we have created a queue item, processed that queue item, and sent the result onto the topic. So now we have to respond from that in the application. And seeing as this is asynchronous, kind of communication, in this case, I decided to use SignalR. Because why not make our demo code as complicated as possible to do something relatively simple? But in this case, we don't necessarily have a good mechanism for subscribing to a topic from our base application and getting the message to the user. So in this case, SignalR makes sense for this kind of toast notification type of workflow. But there is a wrinkle in setting up a web application with a SignalR connection that hits a topic. So the problem is that your SignalR hubs are rather disposable. So they instantiate and break down per request. So they don't stick around forever. And so one way around that is to create something called a service, a hosted service. So you have your web application. That web application is stateless. It takes requests and then processes them, sends back the result, spins everything down. In this case, we have a hosted service, which is kind of like a background process that runs in your .NET application, and is really useful for stuff like this. So in Program CS here, we add a service. We add this topic watcher service to it, and this is a background service and inherits some things. And then the one task it overrides is this execute async task. And so we send it over here to this listen topic. And so we have to do some things that are a little weird because you normally don't have to do them. Specifically, you have to create your scope manually. So this is basically instantiating a scope for our DI container. We pull out services for our service bus handler code and our user hub, which is our SignalR hub. So the way SignalR works is you have a hub, and that hub communicates between different clients. And then what we have here is we have our topic listener method. So we're setting up a topic listener, and then every time we get a new topic item, what we are doing is we are sending that topic to all of the different clients. So we're sending a message based on the result of that topic. So we come into here, scroll down. What we're doing to do that and set that up is we are creating a processor. And so this is something that can process either a queue item or a topic item. So we're doing this in the function app. It did this for us. But in this case, because it's a .NET application, just standard deal, we have to set this up manually, which isn't that hard. And so we create a processor. We drop in our update topic and our subscription. Then what we're going to do is we set up a handle message function. I like to use a local function for this. So basically this handles the message event. And so what we're doing is we are going to deserialize our message body, and we're going to drop it into whatever action gets passed into this topic listener function. So if we look back to our topic watcher, what we're doing is we're passing in an awaited function that sends all that stuff to the user hub. In this case, we are calling that, let's see, gotta go to the right file, calling that in this handle message function. It also requires a handle error event handler, which we can just set up here. So it just logs it, logs the error, and then sends back a completed task. We add that to the processor. So we add it to this process message async and process error async. So if you remember, event handling from back in the day, this should be pretty familiar to you. And then we start processing asynchronously, and this is what kicks off the processor. So when we boot up the application, it sets up this loop and it just keeps it going. And so as topics come in, they get processed. And then in terms of our SignalR hub, that is not super complicated because all it does is just clients send all. So it's just not really, it's just kind of wrapping the method. On the .NET side, or on the JavaScript side of things, that SignalR connection is basically handled in JavaScript. So we just threw it in some site.js or in our site.js file. And what we're going to do is we set up a connection with our SignalR connection hub builder, which requires the SignalR JavaScript library, which you can get from Microsoft. We throw in our URL and we add a build command to build that connection. And then we start the connection, add in a promise, and then we have a handler that goes with that. So when we get the send message event, which we define in the hub, then we basically append that onto a message list item in our code. So each page has a message list, and we just append it on. We could do this with a toast notification or have a specific component that boots this up, whatever we want to do. And so that is the whole workflow here. And the big thing here is that, using the service bus itself is not terribly complicated. But if you've noticed, we had to do a whole bunch of things to kind of get around the fact that everything is asynchronous now. And that can be a little bit of a chore. So it's a little bit more complicated than your standard kick something to a database and send back a result kind of workflow. But it does give you some advantages down the way. Do we have any additional questions on any of this? All right, crickets. Nice. No, I'm just kidding. So with that, let's go to the end here. So yeah, so that's all I got. If you want to learn more about event-driven architecture, I would recommend you go check out the Microsoft docs.